So what is a z-score? The number of standard deviations from the mean a data point is. So in other words, if I were to give a test and I find the mean and I find the standard deviation and I want to look at your specific score, your z-score would be the distance of your specific score from the class average. Okay, so let's do an example of that. So we have Sarah who took a lit exam, and I want to know how Sarah performed relative to 50 other students who also took the exam. So Sarah's score is a 130. The mean for the class is 100 and standard deviation is 15. You'll never need to calculate a z-score, but this is how you would calculate a z-score. Z-score equals the score, the individual student score in this case, minus the mean over the standard deviation. So take a second to figure out Sarah's z-score. Pause the video. Sarah's z-score is 2. That means Sarah scored 2 standard deviations above the mean. What this means is that Sarah scored better than 97, almost 98% of students who also took that exam. So yay for Sarah. All right. The next thing I want to talk about is what happens when we have what we call a skewed distribution. Okay, a skewed distribution means that our results don't fall into a normal curve because we have the presence of outliers. So again, this is what our normal curve looks like. But here's what a negative skew looks like. We've got some outliers down here. So let's say most of the class scored really well in a test, but we have a few people who really struggled. What happens to our mean? It's going to roll down, what we call the tail. So any outliers in a negative direction are going to pull our mean towards that end. Okay? But let's say, for example, I have a test where I didn't really teach well. A lot of people don't do well, but I have a couple people that learned it on their own. The opposite's going to happen. They're going to pull my mean or my average in their direction, in the direction of the outliers. So I like to use the mnemonic, let the tail tell the tale. If you've ever got to figure out, am I looking at a negative or a positive distribution? Look at the direction of the tail. If the tail is moving towards the negative end of the number line, it's a negative distribution. If the tail is moving towards the positive end of the number line, it's a positively skewed distribution. Okay? So there are times when we don't want to use the mean as our measure of central tendency, right? Because if we have a skewed distribution, we just saw that the mean is going to be pulled in the direction of our outliers. So instead, we'd use the median. Let's look at some examples. So you're going to tell me, you're actually going to click and drag in your notebook to indicate whether this is an example of a positive or a negatively skewed distribution. All right. So let's assume that all of our parents are in a room and we make a graph of all of our household incomes. What happens to the graph if Mark Zuckerberg walks into the room? You're going to click and drag what type of skew that is. In our second example, we're going to assume that all the members of the 76ers and the Lakers are in a room and we make a graph of their height. What happens to the graph if I walk into the room, or even some of you? I'm only 5'4". All right, so pause the video, click and drag to where they should be. So this is what we should have. All right, this is what it should look like. All right. Because most of us are going to have incomes down here, and Mark Zuckerberg is going to be our outlier. He's going to pull our mean up. The opposite, we would have a negative skew in this scenario because most of these players are super tall, and then in walks me, and I'm an outlier. I'm going to pull the mean or the average down. So in both of these cases, it's better for me to use the median as my measure of central tendency. The final type of distribution that I want to talk about is called a bimodal distribution. A bimodal distribution is when we have two equal peaks or two modes or two scores that are most frequently occurring. So think about a scenario where I have test results that look like this. I have a lot of students that scored well and I have a lot of students that scored not so well. I actually don't like the labels up here, the did study versus didn't study. I mean, that could be it, but there could be a lot of other factors that are influencing them as well. Let's not pay attention to that. Let's just say we finish a test, I pull up the data, and I see, wow, I've got lots of kids here, and I've got lots of kids here. That means we have a bimodal distribution. So this is a practice example that you're going to do on your own. It's from the 2018 practice test. We've got Mr. Smith and his class performance. Okay, so their mean is 70, and it's showing you that he has a bimodal distribution. So let's look at the problem before you do it on your own. The statewide results of a standardized math test had a normal distribution and a mean of 70. Mr. Smith's students took the same test, and the graph above depicts their results. So now, the statewide results aren't bimodal. The state results are that bell curve. They're a normal distribution, just like we've looked at. So 68% within one standard deviation of the mean, 97% within two, 99.9 within three. You get it. We already talked about normal curves. But now we're looking at Mr. Smith's performance relative to those state tests. So what you have to answer is, what does the mean score of Mr. Smith's class suggest about how well his students are performing relative to the state scores? What does the distribution of scores in Mr. Smith's class suggest about how well his students are performing relative to the state scores? So you're looking at the mean as well as the distribution, which is what we're seeing right here. Okay, so you can turn off the video and go ahead and do this example.